We'll proceed divergence, flux density in calculus. If we have vector field that is algebraic vector and we have area vector that is also a algebraic vector or vector field. What is surface integral of a vector field along a particular area? Along a particular area. That is the big thing. Surface integral means integration of an algebra along a surface. So if I have a function fxy, if I say I have a function fxy, then what is its integration? You are integrating it along xy area, xy plane area, that is dA, dx, dy. What is the integration of an algebra along any area? What is integration of an algebra along any line? What we do is we do integration of an algebra along x-axis, and I say I have done integration, I have done integration. Actually, you are integrating along x-axis. If you try to integrate along xy plane, then it is if you are trying to integrate in 3D where function is fxy, not fxy. I have done in three-dimensional integration fxy. You are doing integration along xy plane by default. So you can do integration along any axis, any line, that is called line integral. You can do integration along any plane. By default it is xy plane, that is called surface integral. Line integral, surface integral. I have done derivation, I have done derivation. You are doing derivation along x-axis. You can do derivation, that is I vector. You can do derivation along any vector, that is called directional derivative along any vector. So differentiation and integration, by default, if it is 2D, then it is along x-axis. If it is 3D, then it is along xy plane. If it is not xy plane, it is any other plane, then it is called surface integral along that plane. So if I have a plane and plane whose kind of equation, if it is a plane, it has a direction, then consider that is a vector field. So if that a vector, a a a means area, a vector is the vector field for the plane, and capital F being the vector field, then it is capital F dot dA vector is the surface integral, integration of an algebraic equation against or along a plane. By default, if I say integration of fxy, then it is along xy plane. Otherwise, I can say capital F dot dA vector. This is the actual complete term of 3D integration. Capital F dot dr vector. That is actual the full term for the 2D integration. If r vector is I and f vector is I, then f vector's first component, algebraic equation, will come into the picture, other will go away. Then it becomes fx dx. Here, if I have algebraic equation capital, if I have vector field capital F equal to f1i plus f2j plus f3 whatever, and area vector is xy plane, xy area vector is d xy plane. If that is the case, then its third component k vector f3. F3, consider f3 is fxy. It's algebraic equation, right? So now it is fxy dx dy. Area into unit vector is area vector, where dA is dx dy and unit vector is k. Now third component of vector field is f3k. F3k will come into the picture. If f3k is small f, fxy, function over x and y, or z, fxyz, whatever it is, then it is fxyz dx dy. So this is surface integral. We have seen too much into surface integral. We have seen too much into surface integral. Now we are talking about surface integral. Surface integral, if vector field is a velocity vector, like a liquid, and area is area, if liquid is passing through an area, then whatever the liquid volume passing per second is called surface integral. If it is a velocity vector field, if that is the case, then it is called flux. I am not saying that velocity is called velocity. Velocity vector field surface integral is called flux. Any vector field surface integral is called flux. Rate per second, rate volume per second if it is vector, velocity vector. Better term is flux. So if I have, consider I have a volume. Volume has many surfaces. Now vector field is passing all the surfaces. Vector field is passing all the surfaces. Then full volume, then how much is the flux that is passing through the volume? That is the question mark. If I take a vector, then typically it is 0, because area has a, consider there are, I have two planes. Now flux is, now vector field is coming and it is passing this plane, then it is passing this plane, then how much is the flux? This plane has area vector along this side, whereas this plane has area vector along this side. If both area vector has net quantity is same and their area vector is just opposite to each other, the net integration will be opposite to each other in the sign. So net flux that is passing through both the surfaces is 0. Is 0. So if I take a cube and place it on xy plane and make a vector field that is going along x-axis, then what is the flux? 0, because one side it is entering as negative and other side it is exiting as positive. 0, up, down, near, front, anyway it is 0, dot product is 0. So what is this? So people kept saying that flux is 0. Okay, if it is not 0, consider a case like we took vector field as minus xi, vector field as minus xi. If you calculate it, it would not be 0. Or very famous r vector divided by magnitude of r to the power 3. When it is kept at origin, then any vector field source when it is kept at origin, and r vector divided by magnitude of r to the power 3. If that is the case, then flux still it will not be 0. If there is a cube that is centered at the origin. Okay, whatever is the case, now the concept is that if I have a volume through which I am calculating the net flux, then flux will be dependent upon the size of the volume, because it is surface integral at the end. What is the power of the vector field? If I need to find, I cannot find it through surface. Like what is the power of liquid that is passing through the surface? If you make surface bigger, then flux will be bigger. Because flux is nothing but velocity into the surface area. If you keep the velocity constant also, then increase the area, then the flux would increase. What is the power of the vector field? Power of the vector field, I have to divide it by volume, not by the surface area. So if I have a cube and through which one vector field is passing, if I calculate the flux divided by the volume of the cube will give me the actual nature of the vector field. So flux would keep growing if volume is becoming bigger and bigger, you divide by the volume, it will come as a normalization. So normalization of flux gives the divergence. What is the divergence? It shows that the source through which vector field is coming, what is the power of the source and where it is. So if I say that surface integral divided by volume, where volume tends to 0. Surface integral divided by volume, where volume tends to 0. If that is the case, if any volume tends to 0, means it becomes a small point. If there is a small point and then I calculate the surface integral and then divide by the volume of this small point, it gives me divergence. Indirectly, you are trying to say what is the power of divergence through that small point, what is the power of radiation through that small point, or what is the power through which it is absorbing the radiation. So I have given example like black hole is absorbing the radiation, it has divergence negative, whereas sun is radiating the radiation, then it also has divergence but as positive. So if that is the case, then when vector field source is kept outside and if I keep a cube and when it is entering and exiting, there is a high chance that the flux density divergence for this cube as far as vector field is concerned is 0 because cube is not radiating. That is the concept. Radiation is coming from outside. Like I am sitting here and I am not radiating. Radiation comes from sun. If I am radiating, then if I switch off all the light and then anyway there is no light now, I am getting light from sun only. But if it is night and if I switch off light and if the light is coming from my body, then there is divergence in me. Okay, that is divergence. Or if there is a light and I'm sitting and I'm absorbing all the light, so everywhere it is dark even though sun is there, then divergence is there in me but it is negative. Now to calculate the divergence, then if I have a point that if I want to calculate divergence at a particular point, then you take one volume around the point. Volume is centered at the point. Now calculate the surface integral of this radiation from this point along the volume divide by the volume of the shape. If you say take 3D shape around this point, divide by the volume of the 3D shape, it gives the divergence. Or, or if you have vector field capital F, then df1 by dx plus df2 by dy plus df3 by dz. If you do that, then also you get the divergence and it is static. It is not a vector field. It just tells the power of the divergence. df1 by dx plus df2 by dy plus df3 by dz. Can you see one thing? Question of there is no question of the surface area, only vector field. df1 by dx plus df2 by dy plus df3 by dz. What it tells? If divergence of any vector field is like this, what is it? df1 by dx. If this is x-axis and this is vector field f1 component along x-axis, then how much f1 is changing when it is proceeding? Can you see this? How much f1 is changing when it is proceeding along x-axis? That is df by dx. df1 by dx, df2 by dy. If this is the y component, if this is the y, this is x component, y component of vector field, then if I proceed in y direction, how much f2 is changing? If this is z component of vector field capital F, that is f3, then if I move along z axis, then how much f3 is changing? If if f df2 by dy, df3 by dz is 0, still df1 by dx is there. This proves that in that region there is a source of radiation. In that region there is a source of radiation. We showed that. Now, if I have a vector field, if I have a vector field that is minus xi, the vector field is minus xi. If vector field is minus xi, and if I am trying to calculate the divergence at center, just see what is df1 by dx, df2 by dy, df3 by dz. Df1 by dx is minus 1, df2 by dy is 0, df3 by dz is 0. Minus 1 means along the x-axis direction there is change in f1, that is seen minus 1. We are trying to calculate divergence at center. This proves that at center the divergence is minus 1. This is origin, this is x-axis, and this is minus x-axis. So at center, if I am trying to calculate the divergence, it is minus 1. Means it is trying to get the absorbing radiation from the outside. That is why it is minus 1. If it was plus 1 like xi, the dz by df1 by dx is 1. Means from origin it is radiating the energy 1. Since it is radiating the energy, we see df1 by dx. Okay, in that fashion. So that is called divergence. Divergence means how much f1, how much this vector field is changing along x-axis, plus how much this vector field is changing along y-axis, plus how much this vector is changing along z-axis. If you add, you get the divergence. I have non-zero dz by dx, non-zero dz by dy, I'm sorry, df1 by dx, non-zero df2 by dy, non-zero df3 by dz. Is it that the divergence can be 0? Yes. If df1 by dx is positive and df2 by dy is negative and equal, df3 by dz is 0, then it will be 0. Like x minus y. Vector field is xi minus yj. df1 by dx is 1 and df2 by dy is minus 1. If that is the case, then divergence would be 0. Someone can try. You can try a unit length cube, place it around origin, and try to calculate the surface integral and check it if it is 0. We can try if I have some time, like consider the vector field is xi minus yj. Then this surface will receive the flux because it is perpendicular like this, and y-axis it is there, so this surface would get the flux. Up and down will not get the flux because flux is only in the vector field is only in the xy plane. So this side, if I calculate for the unit length, then this side it is dy dz, dy dz, dy dz is this. If I take this surface of the cube, then it is in yz plane. Dy dz, the surface integral is capital F dot dA vector. So dA vector is dy dz along I axis, and F is xi minus yj. So j is gone. Now it becomes x dx dy, x dx dy. Then surface integral. Now I am trying to calculate at 1 by 2 because it is a unit length. So from origin, so this surface is x is 1 by 2. If that is the case, 1 by 2 I can keep outside, and dy becomes y minus half to half is 1, dz is 1. So 1 by 2. Now, if that is the case, if I take this side of the, then it becomes, now x is minus 1 by 2 here. So minus 1 by 2 I can keep outside. dy dz minus I, because surface, if I take these two sides of the cube, this side the surface vector is along minus x-axis. Minus minus plus, again half. So half plus half 1. 1 is the, 1 is the net flux through these two surfaces. Now y-axis if I take, this is xz plane, dx dz. Now same thing we will do, but it dx dz, but it is minus y. Just keep minus outside. And now it is again y dx dz, and this side, so two sides. So it will result in 1 again. 1 minus 1, 0. There is no divergence. There is no divergence in the sense at the center at which we are trying to calculate the divergence, there is no energy field that is kept at the center. It is fake one. So xi minus yj is the vector field, then energy source is somewhere outside, not inside the volume, so that it will radiate or absorb. Nothing would happen. So xi minus yj, xi minus yj proves that the divergence is 0. Okay. Now we have seen another case where if it is r vector divided by magnitude of r to the power 3, then divergence is 0. But still we get the flux because this is not continuous at. So the divergence when we calculate through df1 by dx plus df2 by dy plus df3 by dz, then f vector, that is vector field, must be continuous everywhere inside the volume. If I say x minus I minus yj, it is continuous. At origin also it is 0, means it is continuous. But if I say 1 by xi minus 1 by yj or 1 by xi minus yj, then when it is at origin, it is indefinite. At that moment, I cannot do df1 by dx plus df2 by dy plus df3 by dz. That way, I cannot calculate the divergence. Not possible because it is not continuous everywhere. Go with the surface flux calculation through surface area. It is also called geometric way, divide by the volume. That way it can be calculated. Okay, we were doing one example. We were doing one example like, if what about vector field is x square plus y square I plus x y square plus z square j plus z square plus x square k. If that is the in braces x square plus y square I plus in braces y square plus z square k plus in braces z square plus x square k I j k. If that is the case, then what is the divergence of this vector field at origin? So at origin I can take a cube, unit length cube, that is centered at the origin. Calculate the surface integral and then divide by the volume. Volume is 1 only. But calculating the surface integral, with all the 6 faces, someone would start sweating. X square plus y square I plus x y square plus z square j plus z square plus x square k. Now you try uh, capital F dot dA vector integration along all three. Now capital F, what is a vector? If I take these two sides of the, then the dA vector is, one side is I and one side is minus I. Then x square plus y square. First I have to do integration with the dx, and then I have to place the limit for one side, then for another side. Okay, then again for one side, another side for dy, that is y square plus z square. This is simple. If it is even more complex, it is very difficult. Now let's go by the divergence. If you get a divergence and then do the integration with the dv, if surface integral divided by dv is the divergence, then if you have divergence and do integration with the dv, then you get the surface integral. That is also the case. So let's rephrase this question. What is surface integral of vector field x square plus y square I plus x square plus y square j plus y x square plus y square I plus y square plus z square j plus z square plus x square k? If this is the vector field and I have a cube that is centered at the origin of unit length, then what is the flux of the cube that it is receiving on the all sides because of this vector field? One way is calculate the flux the way it should be, capital F dot dA vector. Another is calculate the divergence and integrate it with the dV. You get the flux. So dV is dx, dy, dz as far as Cartesian coordinate is concerned. What is the divergence? Divergence is continuous. Vector field is continuous. Nowhere it is infinite. In that case, x square plus y square, that is f1, y square plus z square is f2, and z square plus x square is f3. Then df1 by dx would become 2x. So 2x plus 2y plus 2z is the divergence. If that is the divergence, 2x plus 2y plus 2z is the divergence, just integrate with the dx, dy, dz and you get the surface. It is far better than x square plus y square and then dx, x square plus y square dy dz I vector for one surface. Again x square plus y square dy dz minus I for another surface. Like that you keep doing double integration for each surface. For 6 surface you have to do 12 integration. Here only 3 integration, and that too equation is only 2x plus 2y plus 2z. So mind blowing research someone has done when the surface integral flux can be calculated through divergence and integrate with the dv. So 2x plus 2y plus 2z, if you integrate with the dx, there is no vector now. Dx, then it becomes 2x square by 2, that is x square plus 2yx plus 2zx. And now integrating is minus 1 by 2 to 1 by 2. Whatever you get, now you will get in term of y and z, not with dy. Then it will be, if it comes as some static, some numeric value plus y, some y, some numeric value, and plus z some numeric value, then it will become now numeric value y plus y square by 2 plus zy, again set minus 1 by 2 to 1 by 2. You will get again numeric and z only, again integrate with the z and then minus 1 by 2, 1 by 2. You will get the flux in flux, net flux. So many things we can do through this formula. Only thing required is that flux has to be the area, the integral the kind of vector field must be continuous inside the volume everywhere. It should not be infinite at any point. If that is the case, then df1 by dx plus df2 by dy plus df3 by dz, that calculation we can proceed upon. Now next is that how can I calculate divergence of a vector field? Consider I have a vector field that is r vector divided by magnitude of r to the power p. We have done it. It comes as 3 minus p divided by r vector magnitude to the power p. That is the divergence. If you see r vector divided by r magnitude of r to the power p, it's a very famous question. If I change it into Cartesian coordinate, then it becomes xi plus yj plus zk divided by x square plus y square plus z square to the power p by 2. Now if I want divergence of this equation, then df1 by dx plus df2 by dy plus df3 by dz, that I have to calculate. So df1, f1 is x y square root of x y x square plus y square plus z square to the power p by 2, where f2 is y, divided by x square plus y square plus z square p by 2. Z is z f3 component is z by x square plus y square plus z square to the power 3 p by 2. So r vector divided by r magnitude to the power p. P is only in the denominator magnitude, not in the numerator. Now there is another fundamental. So this I transform into, rather than computing individually, consider that you have so many variables, so many components, f1, f2, f3, f4, fn. Then how many times now, and this equation is again complex. So first you have to keep denominator and you have to do integration on the numerator, plus you have to keep numerator and you have to do as per the differentiation chain rule. Then for each component you have to keep doing. Then what we see, what we have here, if I say xi plus yj plus zk divided by x square plus y square plus z square to the power p by 2, if that is the case, then there are two things if you see closely. One is algebra, one is vector. I can say 1 by x square by y square plus z square, x square plus y square plus z square to the power p by 2 into xi plus yj plus zk. One is vector xi plus yj plus zk, and other is pure algebra 1 by x square plus y square plus z square to the power p by 2. Can all along I can calculate the divergence rather than field by field. People thought so many things. There are many people, they do not have any other job but to do the invention. There are many people like this. So now if so what we are trying to calculate? We are trying to calculate divergence of a vector field capital F multiplied by algebra G. What is the divergence if I have full as G into capital vector F? Altogether, divergence div divergence in braces G small g, that is the vector algebra, into not dot product, into capital F vector or any vector, rather than df1 by dx plus df2 by dy. If it is so long, and then you understand, right, how much cumbersome it would be. Now I can break it into, I can now divergence of G into F vector as per the divergence formula. It is Gf1 by dx plus Gf2 by dy plus Gf3 by dz as per the divergence formula. If you have vector field capital F and if you want the divergence df1 by dx plus df2 by dy plus df3 by dz, if it is G into F vector, G into F vector, then similarly I can say d gf1 by dx plus dgf2 by dy plus dgf3 by dz. Now, if I calculate the partial derivative of gf1, then first I have to keep g outside and df1 by dx, plus I have to keep f1 outside and dg by dx. If I continue doing like this, then I have two things. One is I have kept f1 outside and dgx by d1. So f1 dgx by dx plus f2 dg by dy plus f3 dg by dz. If I see all together, it is something like f vector dot product of the gradient vector of G. If f vector dot gradient of G, what it would be? F vector is f1 I plus f2 j plus f3 k, dot product with the gradient of G, dg by dx I plus dg by dy j plus dg by dz k. If you do dot product, it exactly becomes f1 dg by dx plus f2 dg by dy plus f3 dg by dz. This is what we are doing. So it is equivalent to f1 f vector dot gradient vector of G. One thing. There is another family that we saw when we were doing. So this is when we keep f outside, when we were doing the partial, we were doing the chain rule of the differentiation. Other is keeping G outside. So if I keep G outside, then it becomes df1 by dx plus df2 by dy plus df3 by dz. That is nothing but the divergence of f. So the divergence of G algebraic equation into f vector is nothing but the f vector dot gradient vector of G plus plus the the G into divergence of f. G into divergence, because divergence of f will give one algebraic equation, G into another algebraic equation, and this side f vector dot gradient vector of G dot product, again it will give one algebraic equation. You add it and you get the divergence. So we will try xi plus yj plus zk divided by x square plus y square plus z square to the power p by 2. This is not my formula, it is available. So if I try this, then first is vector field capital F dot gradient vector of G. So vector field capital F, now I have dissociated into two sides. One is algebraic side, one is vector field side. Algebraic side is 1 by x square plus y square plus z square to the power p by 2, and one is xi plus yj plus zk. Now this vector xi plus yj plus zk dot product with the gradient of G. What is gradient of G? dg by dx plus I plus dg by dyj plus dg by dzk. So dg by dx here, dg by dx. So if I do that with x integration, then it will come as minus 2x minus 2x divided minus 2x. I mean, if I have to differentiate with the x square plus y square plus z square, then it will come as minus p by 2, and then 2x. So 2 will go away, minus and minus px. It will come as minus px. So minus px divided by x square plus y square plus z square p by 2 plus 1. So simple, right? Now if I keep doing, now if I do dot product with xi plus yj plus zk, then it becomes minus px square minus py square minus pz square divided by x square plus y square plus z square to the power p by 2 plus 1. Now that side is G into divergence of vector field f. That is vector field f, that is xi plus yj plus zk. Divergence is 3. xi plus yj plus zk df1 by dx, df2 by dy, df3 by dz. If you add 1, 1, 1, 3. So it becomes 3 by x square plus y square plus z square to the power p by 2. If you settle it down, it becomes minus px square plus minus py square plus minus pz square plus 3 into x square plus y square plus z square in bracket divided by x square plus y square plus z square to the power p by 2 plus 1. How simple it is. Now, if that is the case, then it becomes 3 minus p x square plus y square plus z square. Settle it down, it becomes 3 minus p divided by x square plus y square plus z square to the power p by 2. So, if I have to find divergence of a vector field, I can dissociate it into algebraic part and vector part, and then go with the capital F dot gradient vector of G plus G into divergence of F. F is so small, you have taken out the only vector part, it will be quickly, it can be solved. So many things we can try. Now we will see curl in the divergence, in the flux. We had only calculated flux till now. What about introducing curl factor in the flux? So that we will see.